And welcome back. And it's the 5th of March. It is the Further Maths 5 a day. And let's have a look at the first question. A circle centre minus 6, 4 has circumference 14 pi. Okay. Work out the equation of the circle. Well, this isn't awful, is it? So my circumference is 2 pi r. In order to work out the equation of a circle, I need the radius in the centre. I've got the centre, so it's just about the radius. So therefore, my circumference is 14 pi, which equals 2 pi r, which means that r equals divided by 2 pi is 7. And so it's just going to be x minus minus is plus 6 squared plus y minus 4 squared is equal to the radius squared, which is 49. First question done. Next question. We have a 3D trig. These are always easy or very hard. Shown below is a rectangular based pyramid. The apex is directly over the centre. Well, that's important because that means that if I want to draw, I'm drawing on the base to be clear here, which means the midpoint I can work out by doing half the diagonal. The apex E is directly over the centre of the base of the pyramid. Work out the angle between CDE, which is the sloped triangle, and the plane ABCD. Right, okay. Think about what I'm trying to get to and then work backwards to get to it. So I need to consider the triangle EM, and I'm going to call this point in the middle N. So EMN, and the angle I need is this angle here, which I'm going to call this. Now, do I know any of these values? Well, I know A to D is 8, so the whole thing's 8, which means that this, and let me move my angle to the other side, because then it's clear what I'm about to say. So therefore, I know this length here is 4, because it's halfway across from 8. Do I know the height? I know C to D is 6. Okay, that's not going to help me. And I know C to E is 11 and C to E. Okay, so this is an annoying question. Right, I'm going to have to do something. So I'm going to work over here so I don't try and interrupt that working. So let's consider the floor. So on the floor, I've got A, C, and D. And I know this is 8, and I know this is 6 from the question. So therefore, that means that AC is equal to 8 squared plus 6 squared, which is equal to, well, this is one of these that gives me an exact number, isn't it? So 8 squared plus 6 squared is 100. Square root of 100 is 10. So therefore, AC is 10, which crucially means that NC is equal to 5. Okay, apologies because it's going to be working all over the place here. Please don't do this in your exam, make it much clearer. Then I'm going to consider the triangle that goes from E to N across to C, and then I need this diagonal, don't I? And the reason I need I've got the diagonal, the reason I need this is I need E to N, so I can use it on my first triangle. So I know from the question that E to C is 11, so that's 11. I've worked out NC is 5, which means that E to the N, which is the thing that I need for my original triangle, is going to be 11 squared minus 5 squared square rooted, which is equal to, well, this isn't a nice number, it's 121 minus 25, which is equal to, and it tells me in the calculator 4 root 6, which is the same as, what's that, 16 times 6, isn't it? So it's the same as a root 96. Either's fine. Which now means I know this is root 96, which therefore means that I know theta is going to be, well, opposite and adjacent is tan, so tan minus 1 of root 96 over 4, which is equal to, so inverse tan, root 96 over 4, which is equal to 67.8 degrees. Whew, a lot of working, and again, hopefully you followed what I did. So I kind of started here, and then I went over to here, and then I did a bit of this, and then I went back to this to finish it off. Good question. I mean, not the hardest question in the world, but good sort of thoughtful question. Final question. A curve has equation y equals this. Find the coordinates of the stationary points and determine their nature. So I'm going to do the second derivative. Well, let's just get these done. So dy dx is equal to 3x squared minus 3, not minus 3x, minus 3. Okay, sorry about that. D2y dx squared is equal to 6x. Okay, that would have got me marks in the exam just for working these things out. Then what I need to do is I need to work out where dy dx is equal to 0, and that is where 3x squared is equal to 3, which means that x equals plus minus 1, because 3 divided by 3 is 1, square root of 1 is plus minus 1. What am I doing? The coordinates, okay, so It's one of these annoying questions, isn't it? So if x equals 1, y is equal to 1 minus 3 plus 5, which is equal to, well, 5 minus 3 is 2, so that's going to give me 3. So therefore my first coordinate is 1, 3, and at 1, 3, dy dx and d2y dx squared is what I want, is 6 times 1, which is 6, which is greater than 0, therefore minimum. Fine, got there. Then at the point x equals minus 1, y equals, well, minus 1 cubed is minus 1, minus 3 times minus 1 is plus 3, plus 5, so 8 minus 1 is 7, which means my other point is going to be minus 1, 7. Now I already know that's going to be a maximum, but let's show it anyway because I'm determining their nature. So therefore at, what am I doing? At minus 1, 7, d2y dx squared equals, d2, 6 times minus 1 is minus 6, and that is less than 0, so therefore maximum. Right, present my answers clearly. So my turning points are 1, 3, which is a minimum, minus 1, 7, which is a maximum. Now, just before I continue and finish today, this is a positive cubic, so I know it does that. So I know the one on the left is a maximum, I know the one on the right is a minimum. That fits with what I've got, so I'm happy with my answer. And that's today done. That definitely got a bit harder near the end, and that 3D trig question, that always throws a lot of people. So as ever, do let me know how you've done. Like and subscribe, and I'll see you for the next one. Thanks all.